Welcome to the FTB-810-880 NetBlazer series module presentation. The FTB-880 and FTB-810 modules provide comprehensive, easy-to-use test suites for field technicians to turn up, validate, and troubleshoot DSN PDH, SONET SDH, and Ethernet services up to 10 gigabits per second. The NetBlazer is available in 3 different modules. The FTB-810 provides SONET SDH, DSN PDH testing up to 2.5 gigabits per second. The FTB-8510G tests up to 10 gigabits per second. The FTB-880 allows SONET SDH, DSN PDH, and Ethernet testing up to 10 gigabits per second. This presentation will cover the following transport test application scenarios using the FTB-880. An OC192 BERT case, a DS1 BERT case, an SCS3 with DS1 mapping BERT case, and an NI-VSU emulation. To start the NetBlazer application, from the Mini Toolbox screen, select the module and press on the application icon. It will take a few moments for the application to be fully loaded and ready for use. Let's configure the OC192 bit error rate test case. In the Transport Test Applications section, press on the SONET SDH BERT icon. It will turn orange. It is recommended to use Exfo's qualified SFP transceivers to ensure performance and accuracy of the optical port. You're now ready to set up the test case using the Interface, Global, and Traces Labels tabs. From the Interface tab and the Signal subtab, you can modify the optical structure by using the Modify Structure button. You can choose the transmission and receive rate. You can choose the connector and the mapping pattern that you want to use. We can also decouple the TX and RX and configure them separately. When going from any of the other topologies to coupled, the system will prompt you to choose which direction you want to preserve. We're going to preserve the TX and click OK to validate. We can verify the signal structure and make sure that it is the one we want to use for the test. We have the connector, we have the signal direction beside that, the signal rate, and the mapping. On the right-hand side, we have the topology. Under frequency, we have the TX and RX frequencies, and we can generate an offset, enter a value that we want to use as the offset, and we can use the plus or negative buttons to increment or decrement these values. Under STS time slot, we can select the time slot. Since we're using STS192, we only have one time slot that will be relevant in this case. We can enable the tandem connection monitoring as well as the path tandem connection unequipped. Under pattern, we can select one of the predefined patterns, or we can use the user pattern. When using user pattern, you can enter in the desired pattern and then apply. We are going to use one of the PRBS patterns. The invert checkbox will allow you to invert every bit in the test pattern being used. The RX Live function will cancel the pattern bit error and no traffic identification. The Clock tab will allow you to choose the clock synchronization mode. The available synchronization modes are external, internal, and recovered. When you are using internal and recovered modes, you can configure the clock out parameters. When using the external mode, you can configure the clock in parameters. The clock in parameters are used by the external clock port for synchronization. For this case, we're going to use internal. Now you can also go to the SFP Plus tab in order to view the specifications for your optical module. The optical module parameters will show the vendor name, they will show the part number, we can see the serial number, the speed, the type. Moving on to the global configuration page, the global tab will allow you to configure the bit error, pass-fail verdicts, and service disruption settings. You can enable the bit error pass-fail verdict by choosing either an error count or a bit error rate. You can then define a bit error rate threshold value for the test case. In this case, we're going to use 5. Under service disruption, we can choose a layer in the SONET hierarchy, for example, high order path, and then we can choose the defect, B3 for example. Then we can define a no defect time. In this example, we're going to use 300 milliseconds. We can enable the pass and fail verdict and enter a service disruption time. Here we're going to use 5,000 milliseconds. And we can enable disruption monitoring for the service disruption. We can choose the background traffic in the STS path. We're going to choose unequipped. And for other configurations, we have the synchronization status message, as well as the computation method for remote error indication. We are going to use M1 only. We can also overwrite STS1 fixed stuff column, which indicates where we are using virtual tributaries. We can define a test timer. When disabled, it means that the test will run continuously until stopped manually by the user. We can also use a user-defined value as well. For this test case, we are going to run the test continuously. And of course, we always have the option to restore the SONET SDH BERT default settings with this button down here. We can move over to the Traces Labels tab. Here we can generate a trace. For example, if we go to 16 bytes, we can generate a trace message. We can use the alphanumerical characters. We can also use control characters. The maximum characters is 15. Even though we use the 16-byte format, this is due to the fact that CRC7 will be used at the beginning of every 16-byte format message. If the value is below the 16-byte format, we will see how we can pad it with null or space values. The padding will be over on the right-hand side, where we can choose either null or space values. The same is going to apply for STS path. We can define, for example, 64 bytes. We can again edit the alphanumerical characters or the control characters. When you generate the message, in order to trace the message, you will need to activate the trace identifier mismatch. And for the path, you will need to identify the trace identifier mismatch as well. This will allow you to trace whatever message you are generating from the TX side. Labels is the same. We are able to generate a path, and then we can enable the payload label mismatch as well. Once we are done configuring all the test settings, we are ready to start the test. Once the test begins, the main area is dedicated to results analysis. There are multiple tabs which we will go through one by one. We are going to start by seeing what we have in the menu. Over on the right-hand side, we have the name and the model of the module that is running. We also have the battery indicator. We have beneath that a global indicator with a pass or fail verdict. This will allow us to view current and historical alarms. There is also a global pass-fail indicator there as well. Below that, we have the duration of the test or the test time, and then there are the test control buttons. There is a stop-start button, a button for generating reports. There is a button for saving and loading configurations. There is an inject button for injecting errors or alarms. Beside that, there is a reset button which will allow you to clear statistics and all of the logger content. And there is a laser on, laser off button beside that. We then have the test menus, which are located below. The setup menus are what we went through previously. Then there is the results section and a function menu as well. We will explain the functions a little bit later. Beneath that, we have three icons. One of them is for information on the module, so there is the product version details there. Beneath that, we have the technical support contact information. The module details button will show you the module ID as well as the serial number, so this can be some important information. There is a button for software options. This is where we can see which are the module options that have been indicated, or I should say enabled by the on the module. So options that have a green check mark are obviously enabled. Any of them that have a red circle instead of a green check mark means that they are disabled. We can use a key code license file to enable certain functions. These files can be obtained from customer service representatives. And if you want to reread the license agreement, we can look at it there. The next button in the lower right-hand corner is the information button. This gives us access to much documentation on how to set up tests and how to interpret results. And then this final icon for the X is to close the application. In the lower left-hand side, we have an icon for the application and the name of the application that is running. Beside that, we have the port and the signal direction. We have the signal rate, the received power level. There's a laser on indication and a pattern synchronization indicator. Then there's a color-coded clock synchronization icon. Green means that it's synchronized. And the clock mode indication showing here that we are using an internal clock. There is an OH icon for overhead. This means that we are not using the default overhead values. To look at the overhead values, we can go to the Functions menu, and in the Overhead tab, we can reset the default overhead values. The Summary tab will give us a summary of the test case in progress. The status here shows that the test is in progress, and the verdict is that it is passing. The start time will appear over here on the right. In the BERT section, we can see the results of the pattern loss, if there are any current or historical alarms. Beneath that are going to be results for bit errors in elapsed time, in count, and in rate. We have a bit error rate threshold value here displayed at 5. There is a bit error counter. Now green indicates that we are below the threshold value, and red is going to indicate that we are above it. There's a green arrow to the left-hand side, which is going to indicate where we are in the counter. So to inject some errors, we can go over to the right, and we can manually select manual. Then we can define an amount of errors that we want to inject. By pressing the inject button, we will see that we receive a bit error, in this case, which is above the threshold, and we can see in the counter where it is. Now we can reset the test to clear this information. From the Summary tab, we can also monitor the information about the service disruption times. We can see the service disruption count. We can see the service disruption time threshold as well. Earlier we had defined a B3 error. Now we can go to the Alarms tab and inject an error which will appear in the service disruption time results. We can define the layer, the path layer, we can choose the type of error, type of defect. We can select B3, the mode of transition, which is going to be rate. We can define the rate as well, and we can start the injection. So here we have the B3 alarm. So we can stop the injection, and if we move back to the summary page, we will see that the disruption count has increased to 1. Now we can start and stop the injection and see the count increase to 2. We also have the indication on the status bar that the injection is being processed. Now you can stop the injection, we can clear the test, and this is how we simulate a service disruption time. In the frequency section, we have the receiving frequency as well as the maximum offset values. Under Alarms and Errors, we have reviewed that we can generate alarms. You can generate alarms and monitor the receiving signal. You can monitor alarms from the interface section, and alarms and errors from the section and line layer, as well as the path layer. And we can also monitor the BERT alarms and errors. We can expand some boxes when they have many information fields. You can expand the box to have a detailed view of the layer. We can move on to the Performance Monitoring tab. Each of the Sonnet layers have details: the section, the line, the path, as well as the BERT. For each layer, we have the standards supported. Here we have the G829 in-service monitoring. You can monitor the near-end and far-end results. Here it indicates that we are running error-free. So for example, 92 seconds error-free. No other results indicate errors, so this layer is error-free. If we move to the line layer, We can see if we have any indication of errors. If we have any alarms or errors, an exclamation mark icon will appear on the side. Let's go back to the alarms and errors page and inject some errors. We're going to choose the layer, interface, loss of signal, and inject. Now we'll move back to the performance monitoring. Now we can see that all the layers have an exclamation mark, which indicates that at these layers we have some issues. So we're going to stop the injection and reset the test. We can go to the Traces Labels tab. Here you can see the received traces that are being sent. We can also see the labels that are being received. From here we can copy the traces that are being sent to the traces that are being sent from the Section tab. And if we enable that, we can also copy the path trace to the receive trace, and we can see that the alarm goes off. In case we change the value here, we see that the expected value is different than the receive value, and we'll have a trace identification mismatch. When you copy the send to the received, the alarm is going to clear. Now the same goes for the labels as well. If we move to the Logger tab, the logger records events that took place during the test. You can sort the display by identification, time, or by event. We can select the time mode, also as being absolute or relative. Relative meaning that we are showing times as a function of the start of the test. So we have the time, we have the events, we have the duration, and the details of all the events that are recorded. If we go to the functions page, we can monitor the round trip delay. The mode can be single or continuous, and we can measure the round trip delay. Here we can see the last measured value. We can see the minimum value, the maximum value, and the average. We can choose the continuous mode and have measurement counts continuously compiling down here. We can always reset the statistics and continue the measurements. Under APS, Automatic Protection Switching, we can configure the switching mode, which is ring or linear. The default is linear mode. And we can configure the K1 and K2 values for TX as well as RX. Under pointer adjustment, we can use a manual pointer adjustment by ensuring an increment or decrement value and pressing on buttons to validate the steps. Once this is done, you will see under the RX pointer adjustment, we will see beneath it the counter of the pointer increments and decrements. We can jump to a new pointer value by injecting a value here. And under the receive pointer adjustment, your value will be 5. And the cumulative value is the difference between the increment and the decrement pointer values. This is automatically reset when you are using a new pointer jump. You can also enable a new data flag to be injected along with the new pointer. In this case, we see that we have a counter for the new data flag. We can use the sequence in order to adjust the pointers as well. We have the standard on the left, and the pattern can be chosen on the right. We can increment or decrement the pointer values, and we can enable or disable the initialization and cooldown processes before applying the pointer sequence. If we disable it, then it goes automatically to the pointer sequence. We can press on the sequence button in order to apply the pointer adjustment, and under RX pointer adjustment we have the pointer value and the cumulative offset that is being shown. If we look at the overhead, we have the transmit and receive overheads for each of the Sonnet layers. We can choose the time slots that we want to use. And from there, we can change the values of the bytes if we want and apply them. If we change the value of D1 here to, let's say, 23, well, then we can see that the change is applied to the RX side, D1. Header, and see the bits down here. Once we are done with the troubleshooting, we can go to the default all overhead button and set everything back to the default values. We are now done with the functions menu. When we are done with all of the functions, we can reset the test case. Once you've stopped the test, you'll be prompted to generate a report. Choosing to generate a report will cause a window to appear for entering information into the fields here. So we have the job ID, contractor and operator names, the comments section, customer name. We can change the report headlines and content. You can change the header, the title. You can also choose to include or exclude the logger in your report. Under the Save Report area, you can type the file name that you want to use. You can choose where you want to save the report. It's either going to be internal flash or removable storage disk. You can choose to display the report after saving. You can turn on or off the report generation prompt. The format can be either PDF or HTML or text, and you can insert a logo in the report. You can insert other logos by going to the File Manager, the FTB-880 NetBlazer folder, Reports folder, Images. It is here that you can copy or paste other logos for use. When you're done with the setup, you can save the report. The Open tab will allow you to open previously saved reports, either from internal flash or another source. The Import-Export tab lets you copy files from one media type to another. So we can copy from the internal flash to the removable disk, or vice versa. We simply need to select the file and press on the copy button. Now, something else to remember is the Save and Load Configuration button. Once you're done with the test, you can save your configuration by pressing the Save Load button. From that menu, you can choose the media where you want to save. You can choose the file name or the name of the configuration, and then click on Save Configuration or Save Config. Here in the Factory Defaults section, you can turn on or off the Restore Default at Startup prompt, because whenever the application starts, you will see that that prompt will appear. And you can restore the default setting for this as well with a button over here on the right. The Import-Export button is for file management of configuration files from one media to another. Again, we simply select files that we wish to copy from one media to another and click on Copy. This concludes the Sonnet SDH BERT test case. To set up a DS1 BERT case, press on the DSN PDH BERT icon. For a more detailed walkthrough of this setup, please consult the Sonnet SDH BERT Test Setup chapter. Once the application loads, down at the bottom there is an icon representing the DSN PDH BERT test. Now we can modify the structure. We can choose DS1 as a rate. We will use Bantam connectors, and the DSN setting will be pattern. In the topology section, we have another topology which is dual RX. This is because we are able to perform a dual RX monitoring with the DS1 test case. We verify the structure. At the top, we can see that we have the Bantam connector, the signal direction, the signal rate, the pattern, as well as the topology. On a DS1, we can set the termination mode, bridge, monitor, or term. We can use different amplification for line build-out, for different cable lengths that we have. We can select the line coding, AMI or bipolar with 8/0 substitution. We can choose the framing type, extended superframe, Slick 96, superframe, or unframed. Now we can choose to monitor the DSO channel. We can modify DSO channels here, and we will have the DSO size, either 56K or 64K. We can choose the zero code suppression scheme that will allow us to overwrite the idle or tone channels. We have the payload content that will allow you to overwrite all the channels, or the time slot by pressing the Set All button. We're going to use pattern for all the channels. Under DS1 loopback, you can choose the loopback code words that you want to send. And you can modify the codes that you want to send by pressing Modify Loop Codes. It will give you configuration for the different codes available from code 1 to code 10. Under frequency, we have the TX frequency and RX frequency. We can generate an offset by manually entering in a value and using the plus or minus to change this value. Under pattern, we can select the test pattern that is going to be used. We can also select a user-defined pattern. The invert button will allow you to invert the bits in the test pattern that is being used. The live traffic button will cancel pattern loss, bit error, as well as new traffic in indications. We can auto-detect the signal by pressing the button, and it will indicate the line coding, the framing, as well as the test pattern being used. Auto-detect is not available when the test is started. We can go to the clock tab and choose the clock synchronization mode, as well as the clock in and clock out parameters. We can go to the Global tab for the configuration of the DS1 test. Here we can set pass-fail verdict for the bit error, as well as for the service disruption. We can generate the background traffic by using all ones or all zeros. We can define a test timer for the test. We can also restore the default DSN PDH BERT settings. We are done configuring the test case. We can now start the test. The Summary tab will give you the status of the test case, which is in progress. The start time is indicated on the right. We have the BERT alarm monitoring, like for the OC192 test. We also have the service disruption results, and the frequency information is here as well. Under the alarms and errors, we will be able to expand the control box and generate errors at different layers of the DS1 signal. We can use the Performance Monitoring tab and see the performance monitoring at the DS1 and the pattern being used. Under DS1, we have the standard G826 in-service monitoring, as well as the M2100 in-service monitoring. For the BERT, we have the G821, as well as the M2100 out-of-service monitoring. Out-of-service measurements on this. You can monitor the different results for near end and for far end under these tabs for performance monitoring. We can move to the Logger tab, and we have the same presentation of the logger. We will see the information for the different events recorded by the logger during the test. If we go over to the Functions page, we have the Facility Data Link function with bit-oriented messages and the Performance Report messages. We can generate a priority code word, inject the priority code word, and we will see the link activity on the receive side as well as the code word received. Now we can inject that and we'll have the link activity showing the current and previous priorities received. For the command response section, we can also send some code words, define an amount to inject, and press on the inject button to send. The link activity shows us that we received command response code words, and once the injection is done, the link activity goes back to idle. We have unassigned code words that we can use. These can be injected as we can see in the link activity. We can go to the Performance Report Message tab and generate some messages. The choices are CI to Network and Network to CI. Now we can check or uncheck the standard. In order to choose the standard settings, here we have the event that we can inject, and the injection method is going to be single or continuous. We can inject the G1 event, and we see that we have counts that are going to increase as time goes by. We can go to the Report Content tab to view the performance information details. We can move to the Round Trip Delay tab. Under the Round Trip Delay, you can measure it by using single or continuous mode, and press on the Measure Delay button. To configure an STS suite with DS1 mapping, select Sonnet SDH DS1 PDH BERT test. We can modify the signal structure in the Interface Signal tab. Here in the menu, we're going to use the STS3E rate. The connector type is going to be BNC. Sonnet, we're going to choose Sonnet Mapping STS1 and Virtual Tributary 1.5, and then DS1 and Pattern. Now we can verify the signal structure. We can see the port that is used, the signal direction, the signal rate, and the mapping. And on the right is the topology, which is coupled. Under STS3E, we can configure the termination mode. We have the line build out for the cable type, and then we have the line coding. Under DS1, we have the framing type that you can use. And under DS1 loopback, we can choose the different loopback code words that we want to use when looping up and looping down a remote CSU or NIU. Under pattern, we can choose the pattern that is going to be used during the test. We can modify the loop codes 1 to 10. Here we are going to choose the CSU 10,100 loop up, loop down code word. Under frequency, we can monitor the TX and RX frequencies and generate offset by inserting a value and then modifying it with the increment decrement buttons. Under STS and virtual tributary, we have the STS time slot that we can use for the test. We can choose to enable tandem monitoring connection as well as the path tandem connection unequipped by unchecking or checking the boxes. You can choose the virtual tributary number by pressing on the box and choosing the number that we need. And we can enable or disable tandem connection monitoring and virtual tributary tandem connection unequipped. Under the clock tab, we have the clock synchronization mode, as well as the clock in and clock out parameters that we can configure. Under the global tab, we have the bit error rate pass-fail verdict configuration. We have the service disruption pass-fail verdict configuration, and the background traffic that you want to use for the test, for the STS path, for the virtual tributary paths, and the DSN. Now we can choose a synchronization status message to send across the network. We can define a duration by choosing a predefined value or leave it disabled to leave the test run continuously. You can reset the Sonnet SDH DSN PDH BERT details by pressing the button. If we go over to the Traces Labels tab, we have the Traces message to be generated, as well as the Expected Values section, and we can enable Trace Identifier Mismatch for the section, the path, and the virtual tributary. In the Labels section, you can generate the labels for the path and virtual tributary, and then monitor their values by checking and unchecking the payload label mismatch for the path, as well as payload label mismatch for the virtual tributary. We can start the test, and we can view the results of the test in the Summary tab. We will see the status of the test, as well as the start time. And under BERT, we have alarm indications for pattern loss and for bit error. They will both be displayed in seconds, and for bit error, we will also have the count and the rate. We have the graphical counter of the bit error rate, and you can inject bit errors here on the right. Beneath, we have the service disruption monitoring. Here we did not enable the service disruption time threshold, so no threshold has been entered. We can also verify the receiver frequency and see if we are synchronized or if the clock is synchronized. Under the Alarms Errors tab, we can inject alarms or errors at each layer. We have the High Order Path layer, the Virtual Tributary layer, the DS1 layer as well. And we also have interface section line sections as well. The BERT layer is where we have alarms and errors as well. You can inject an error and you will be able to monitor that error. Here we have a historical alarm for a bipolar violation, and we can clear the statistics results and logger content by pressing on the reset button. From the Performance Monitoring tab, we will be able to monitor the different layers' performance. We will be able to monitor the near end parameters and the far end parameters when applicable. This is valid for the section, the line, the high order path, the virtual tributary layer, the DS1 layer, as well as the BERT. We can go to the Traces Labels tab where we can monitor the received traces and see if they are matching with the expected traces. Same for the labels. We'll be able to monitor the received label and to match them with the expected labels. Finally, if we go to the Logger tab, this will allow us to see different events that are recorded during the test, such as the ID, the time, the event, the duration, and the details. If we go to the Functions tab, we have the Automatic Protection Switching configuration, where we can configure the switch mode, as well as the K1 and K2 values for both TX and RX. We can move to Pointer Adjustment and use Manual Pointer Adjustment or Sequence Pointer Adjustment, and we'll be able to monitor the pointer adjustment under Receive Pointer Adjustment. We can do that for the higher order path and the virtual tributary. We can move to the Overhead tab where you can select a time slot and then change the time slot and monitor the section, line, high order path, and virtual tributary bytes. Under Facility Data Link, we can generate some messages. We can generate under bit-oriented messages and then monitor the received messages over here. Under Performance Report Message, this is the same, and we'll be able to generate messages and view the received messages. Under Round Trip Delay, we can measure the round trip delay by choosing single or continuous mode, and then press on Measure Delay in order to measure some times. To start the NICSU emulation, press on NICSU emulation from the menu. Under the Interface and Signal tabs, you can modify the structure. You can choose the RJ48 connector. Under DS1, we have the termination mode, that is term. The line build-out amplification will allow us to use different amplifications for the cable lengths that you are using. There is line coding, framing, and we can monitor the receive frequency as well as the clock synchronization status. Under DS1 Loopback, we can choose the loopback mode as manual or auto response. We are going to choose manual and choose line and then activate the loopback. Once you activate the loopback, you are in loopback mode and will be looping back traffic. We can release the loopback and then use the auto response loopback mode. That will allow you to use the receive loopback codes from a remote unit, and we can be able to reply to that loopback and loop back the device. We can also force the release of the loopback by using the force release button. Once you are in loopback mode, you can start the test. We can analyze the results from the summary tab. The status shows that the loopback is active. We have the interface, alarms, and errors beneath that. We are showing the receive frequency, the offset, the maximum plus offset, and the maximum negative offset. We can move to the logger tab, and that will show us the different events recorded during the test. Under functions, we can monitor the bit-oriented message from the Facility Data Link tab. We can also monitor the performance report messages. I can generate a priority code word, and the link activity shows that I'm receiving a priority code word. I can also generate a command response code word, and the link activity will show that as well. If we move to the Performance Report Message tab, we will be able to generate bit events and monitor the bit events on the test set. This concludes our overview of the FTB-880 NetBlazer Multi-Service Tester. For any questions or comments, please contact Exfo's technical support.